Well, good morning from beautiful Gippsland and Honeysuckles Astronomy Tours headquarters. Today I'm going to talk about eyepieces. Now, eyepieces are a very important part of astronomical equipment, not surprisingly, but they're a little bit like, well, bottles of wine. Any bottle of wine will do, but the better the bottle of wine, the nicer the taste. So as a general principle, let's work with that with eyepieces, because it's pretty well true. Now, I've got a variety of telescopes, but the main telescope I use for my tours is my large 20-inch reflector, which I'll just show you here. I'll put it on the way it is. It's in storage at the moment. It's got a heater keeping the main primary mirror warm down the bottom. That's on a very low temperature, but it keeps the glass in the mirror slightly higher than the air temperature around it to keep condensation from forming. And so the mirrors, the eyepieces that I use primarily to function in this type of telescope. So what have I got? Well, I've got three types of eyepieces. The two that I use the most, the types of eyepiece that I use the most, are a Pentax eyepiece and an Explore Scientific eyepiece. But I also have Takahashi eyepieces, these little fellas here. Now, they're all quite different, these eyepieces, but nonetheless they can all be used interchangeably. What you'll notice immediately is that the Explore Scientific, these three, are a 2-inch eyepiece. So they've got a 2-inch diameter barrel, whereas these ones are a 1 1/4 inch, the Pentax and the Takahashi. Well, that's fine, because I can use an adapter in the telescope to accommodate both. So whether I want to use a 2-inch or a 1 1/4 inch, I put this in the telescope and it'll accommodate both eyepiece sizes. Now, with eyepieces you have a number of sets of lenses within the barrel itself. They vary in number, but 6 or 7 is towards the upper end and 4 or 5 is more towards the lower end. And you also have, these lenses have coating on them, which helps to reduce reflective glare with light coming through the object you're looking at, and contrast. So the idea is that the better quality of the lenses within the eyepiece itself, the more lenses, or the better coated they are, more and thorough coating they have, the better the reproduction of the light you're getting through the telescope. And the telescope itself is the instrument that generates the light power. That's where the power is in a telescope. Power is not in magnification, it's in light gathering capacity of the telescope. And once you've got that light gathered by the telescope, then you use the eyepiece to magnify the image and also provide other qualities. The better the eyepiece, the better quality the image you'll get, but also, and importantly, different eyepieces provide different sizes of fields of view. Now, field of view is the amount of space you're actually looking at when you're looking through the eyepiece into space. For instance, if you're looking at a full moon, you might see the full moon occupies about half a degree. Now, depending on which eyepiece you've got, you might see the full moon occupying the full screen. Whereas if you've got an eyepiece that offers a wider field of view, more degrees of your field of view, that same magnification but in a different eyepiece with a wider field of view, and you might be able to see 2 moons next door to each other standing side by side. In other words, a lot more dark sky is around the subject, but the subject is still the same size. So in looking at different objects in the sky, it can be very useful and important as to which eyepiece you select and which eyepiece you choose to have in your collection. Now, the Explore Scientific eyepieces, they're large eyepieces, they're heavy eyepieces, and they're quite expensive eyepieces. These have a 100-degree field of view. Now, when you're looking at larger objects like the Orion Nebula or galaxies, larger galaxies, close galaxies, or in some cases planets, and you want to see some lots of sky around it, or star clusters. Lots of times you'll use, frequently you'll want to use an eyepiece that gives you a 100-degree field of view, because you're just getting more sky to see, so you can see a lot more in it. Whereas the Pentax has a 68-degree field of view, so it's a smaller field of view. As you can see, I've got 20 here and 20, focal length 20 and 20 here with these two eyepieces. But this is a 100-degree field of view. This is a 68-degree field of view. So, for instance, if I was looking at something that didn't need, or I didn't want necessarily a large field of view, I might select the Pentax. Whereas, as I said before, if I wanted something that had a bigger field of view, because I needed more space to see the object fully, I might go for the Explore Scientific eyepiece. The other night I was looking at Saturn. Now, 20 magnification only, the 20 mil eyepiece only gives me a magnification in my large telescope of about 120 times. But most of my viewing is done between 100 and 200 magnification. You don't need to be looking up at 400 or 500 magnification to say you've got a powerful telescope. You'll get a beautiful view through a big telescope of 100 to 200 magnification, depending on the object you're looking at. Now, when it comes to planets, where you want to get a bit closer to see more surface detail, then for instance, the 10 mil Pentax will give me 250 magnification. That's a fabulous magnification on planets like Jupiter and Saturn when the viewing conditions are good. That is a fabulous magnification, but it's only 250, which to some people might think, oh, that's not very high, but it's quality, not quantity. Higher magnification is no substitute for a good quality clear image at a lower magnification. The eyepiece that I use occasionally is this Pentax 5mm, which would give me a 500 magnification, which I'd only ever use for the planets on very, very good viewing nights, or there's a couple of other deep space objects that I have occasionally used the 5mm on. The Carina Nebula, the homunculus cloud. Those of you who know a little bit about the stars will know what I'm talking about when I try to see the homunculus cloud with a 5mm eyepiece. That's to get a good clear view of it. But the different eyepieces have different characteristics which lend themselves to different observing targets and different sensations that one wants to achieve. The other night, as I was saying, when I looked at Saturn, I looked through the 20mm eyepiece, the Explore Scientific, which gave me the 100-degree field of view, and Saturn looked fabulous. It was not big in the view. It was certainly big enough, and you saw the rings clearly and beautiful detail on the planet, but you saw many, many moons dotted around the planet, and lots of dark space around the main objects as well, which gave it a fabulous feel about it. And that was only at 120 magnification, but it was a glorious view. And over here with my Takahashi eyepieces, these only yield a 52-degree field of view, so I don't use these as much because there's a degree of duplication here. What's the Takahashi and the Pentax would have a lot in common from the point of view of when I could use them. So I tend to choose the Pentax over the Takahashi usually because of the extra field of view. However, if I'm looking at for instance, if I'm looking at a planetary nebula, which is a star that has blown itself out and has gas around it, which is often colourful, and you're left with a remnant dwarf star at the centre. They're not large objects, but they really demand good sharp viewing, if at all possible. And so I'll often use one of my Takahashis to look at planetary nebula. And one that I probably go to the most is the 18mm or the 12.5mm, which again gives me magnification in the 100 to 200 range, although the 12.5mm is slightly over that. But that's the eyepiece of my choice through this large telescope. However, if I were to use my refractor, and I'll just show you my little refractor telescope for a moment. I don't use that for public nights, but or for viewing nights. But this is a William Optics 110mm refractor. It's got a primary lens at the top end of the telescope here. This is a refractor as opposed to a reflector. This has a lens in it. My large telescope here that I use for my astronomy tours has a very large mirror. But and the eyepiece goes in here. Now this refractors produce very, very sharp views, lovely views, very sharp views. Now looking at the moon through that telescope with my Takahashi eyepieces here produces the most stunning sharp views, absolutely amazing. So that's just one of the one of the different ways about skinning the rabbit, as it were, astronomically viewing wise. But equally, when I look at the moon through my large reflector here, it's a beautiful view through either of these two. But for sharp, crisp viewing, not as high magnification, but sharp and crisp through the refractor with these Takahashi eyepieces, you can't beat it. Anyhow, so look, it's a little bit. That's a little bit of a tour on the eyepieces themselves and how they vary. These are my go-to mainly because of the 100-degree field of view, which is really special. These I look at nebula and star clusters and planets, and these I would look at for planetary nebula, or with my refractor, particularly with my refractor I would tend to use these eyepieces more. So anyhow, look, I hope you've enjoyed that. Give us a like if you thought that was of interest, and I look forward to seeing you at Honeysuckles Astronomy Tours sometime, and maybe I can show you a few of these objects through some of these eyepieces. All right, look forward to seeing you. Bye.